Hi there, this is Kevin Patton with a brief audio introduction to episode number 54 of the A&P Professor podcast, also known as TAPP Radio, an audio pageant for teachers of human anatomy and physiology. Let's preview the topics of the upcoming full episode, that is episode 54. One thing I'm going to discuss briefly is why you might want to consider getting your next vaccination at noon and not, let's say, at midnight. because I know that's when you usually get your vaccinations, right? At midnight? Okay, maybe not. But it does matter, it seems, what time of day you get vaccinated. And if you want to know more about that, you're just going to have to tune into the full episode. Something else I'll discuss briefly is a newly discovered population of neurons in the brain that seem to actively erase old memories that we're not using. So what's that all about and why is that important? Once again, tune into the full episode. And I will also briefly discuss vaping. How can I not discuss vaping? How can any of us not discuss vaping? You know that you have students coming in class or after class or whatever, bringing up this issue of vaping. And so this is an issue that we all need to keep up with. So I have a few words to say about that in the full episode. The featured topic of the full episode is learning outcomes, specifically the new learning outcomes document that has just been released from the Human Anatomy and Physiology Society, HAPS. Now, HAPS has had learning outcomes for anatomy and physiology for a long time, but they haven't been revised in a while. And so they've been recently revised, and there are some changes, actually quite a few changes. So I'm going to introduce you to some of those changes and talk about why it's important to look at that document and some ways that we can use that document to make our courses better. So that's all coming up in the next full episode, episode 54. The free distribution of this podcast is sponsored by the Master of Science in Human Anatomy and Physiology Instruction, the HAPPY degree. I'm on the faculty of this program, so I know the incredible value it is for all A&P teachers, whether rookies or seasoned veterans. Check out this online graduate program at nycc.edu/happy. That's HAPI. Or click the link in the show notes or episode page. It's time once again for Word Dissection. This time we have a lot of terms to cover, and I say that a lot, don't I? But we often do have a lot of terms to cover, and so I will once again say we better get going. And the first two terms we're going to take together because they're very closely related to one another. These two terms are isovolumetric and isovolumic. Isovolumetric is a term that you and I use all the time, right? When we're talking about the cardiac cycle, we may use the term isovolumetric ventricular contraction to describe one phase of that cycle. And isovolumic or isovolumic means the same thing. The difference between these two terms is that metra word part. So let's do the dissection so we can more clearly see the difference between these two terms. So taking the first word part, iso, we know that means equal or same. And then volume or volume literally means something that has been rolled up or something rolled. And it originally referred to a scroll, for example, or a roll of sheets that's all rolled up. And it can still mean that, but the term volume, ordinary English word, has taken on a variety of other extended meanings, including, in a very broad sense, it can refer to the quantity of a mass, the size of a mass, so that's volume. And then we have the metra part, which literally means measure, and IC is relating to. Now looking at that word part, metra, it means measure, literally, but a lot of times when students see it, they're thinking meter as in a measurement of length. So they think of it as implying length. And sometimes it does, depending on what word that word part is in. It depends on the context. And for that reason, at least this is my understanding, for that reason, when we're talking about isovolumetric contraction, we don't really want to focus on the length of the ventricle. That's not really part of what we're trying to describe. And it could be confusing, so we can take it out, and there is a word that takes it out, and we can use that, isovolumic. So instead of calling it isovolumetric ventricular contraction, we can call it isovolumic ventricular contraction. And that is a trend, and we're going to be talking about it in one of the segments of the upcoming full episode, that is episode 54. Now, another pair of terms, we're going to take two together again, and that is hematopoiesis and hemopoiesis. So let's start with hemopoiesis. Hemo is a word part that means blood. Poiesis is the process of making something, or we could just simply translate it as making. I love that word because whenever I'm doing a dissection that has that term in it, I immediately recall that it's from the same root as our word poetry, which is making something out of words, right? So it's very poetic. No, I said poetic. It's very poetic. Poetic is very poetic. Oh my gosh. I shouldn't have even started that. Anyway, hemopoiesis is blood making. Okay. What about hematopoiesis? Well, that word part hemato is just another variant of the word part hemo. So they literally mean the same thing. Both terms mean blood making. But in the context of modern hematology and cytology, there is a distinction where hematopoiesis is that overall process of making blood cells from stem cells, that whole set of processes that occurs. But hemopoiesis is a subset of that, which is referring specifically to the myeloid and lymphoid making of cells that, of course, is a big part of the picture, but not the entire picture. So we're going to talk about that distinction in the upcoming full episode number 54. Let's move on to our next term, vaccination. Now, this is a common English term. Boy, it's used a lot these days in the media and elsewhere, right? Because there's this unusual conflict about whether vaccination should be given or not. And it's the lack of vaccinations really causing some problems in our society. But we'll get to that later. Let's look at the word parts. Let's start with the very first part of that word, which is vaccine, really, and let's break that down. The vaca part at the beginning, that literally means cow. The "ine" part means relating to. So vaccine means relating to a cow. So what does that mean? How did that get in the word? Well, we coined a term, vaccine, that is vaccinae, which means cowpox. That goes back hundreds of years that we called that disease cowpox that cows get. Humans can get it too, but it's associated with cows. And vaccine literally means relating to cows, and that was the disease in which or for which what we think of as the first vaccine was developed. Edward Jenner, back in the late 1700s, took material from the cowpox disease that had the active pathogen in it and gave it to people who weren't sick. And it made them sick, but it also imparted some immune resistance to getting not only cowpox, but the related pathogen, smallpox. So that was the original vaccination, and it was for smallpox. And as other vaccines were developed, we just kept that name, vaccine, even though it wasn't for smallpox and was not related to cowpox or cows at all, necessarily. And so we just, became a more generic term. And then, so that's vaccine, but we're talking about vaccination. So the AT converts a term to a verb. So if you vaccinate, then that's the action of applying a vaccine, of administering a vaccine. And then the ION ending is a condition resulting from an action. So the AT converts it to a verb, and then the shun part, the ION part, says that's the result of an action. So a few days ago, I had a flu vaccination. I got a vaccine. What the pharmacist did was vaccinate me. So they're all variations of the same term. And of course, those word parts help us distinguish which variation it is that we're talking about. And we're going to talk about vaccination in the full episode. The next and last term is a term also that will come up in the full episode, and that is the Cd8 cell, or we could say the Cd8 T cell. The CD, it's capital C, capital D, and then the numeral 8. So that's all pushed together into a term. CD is an acronym that stands for Cluster of Differentiation. Now, there are some other ways of expressing the meaning of that acronym. Some people use the term classification determinant or cluster of designation, but most often we use the phrase cluster of differentiation, and that is an international system for naming the surface markers on blood cells so that we can distinguish different categories or classifications of cells, because different blood cells, particularly white blood cells, are going to be doing different jobs in immunology, for example. So we use the term CD a lot, which, let me tell you what the numeral means. The numeral is the specific marker that makes that category that category. So if you have an 8 at the end, well, that 8 designates the particular marker associated with the number 8 in this system. And if it's CD5, well, then that's a different marker. And then at the end, you may have a plus sign. And if the plus sign is there, that simply means that the cell is positive for that marker. So if it's CD8 plus, all that means is that, it's got the 8 marker. It's got that CD marker. So that's what CD8 means. And if we're applying it to a T cell, T stands for thymus, and that's a category of lymphocytes that did at least part of their development in the thymus. And so T for thymus. This podcast is sponsored by HAPS, the Human Anatomy and Physiology Society, promoting excellence in the teaching of human anatomy and physiology for over 30 years. Go visit HAPS at theapprofessor.org/HAPS. That's HAPS. Yep, I have another recommendation from the A&P Professor Book Club. And this one is a book that I've just started reading, and I'm really enjoying it. It's called Human Errors, a panorama of our glitches, from pointless bones to broken genes. And it's written by Nathan H. Lentz, that's Lents, and he's a biology professor, and you can really tell, because we all know, if you're a regular listener of this podcast, you know that good teachers have to be good storytellers. And Nathan Lentz is a good story. He's a great storyteller, and I'm really enjoying the story he's telling in this book. Just to give you an idea of how he frames his story, when he talks about human errors, he's talking about the fact that the human body is not perfect in terms of its structure and its function. That we do a lot of things well, certainly well enough to survive as a species, but it's not perfect. There's still a lot of room for more efficiencies, and some parts of our body are prone to certain dysfunctions and so on. And his point that he's making in this book is that that's the way evolution works. And a lot of us as humans, not necessarily those of us who are biologists, but humans in general tend to think of humans as sort of the quintessential organism. That is, the perfection of evolution, the best, most efficient, most whatever, hyperbolic being that evolution has produced. And he's pointing out that no, that's not how evolution works. It can't work that way. So he's got 3 categories of errors, if you want to call them that, and this is what he calls them for the sake of telling his story. 3 categories. The first category that he talks about are aspects of our structure and function that evolved in a world that is very different from the one we live in. Given our modern environment, given our modern culture, given our modern way of life, our diet, and so on, things don't always work out as well as they should based on the fact that we're eating and living and moving around differently than we evolved to do. With evolution, it sometimes takes a very, very long time, and so therefore, not everything can change as quickly as we are changing in our environment and in our habits and so on. So that's one category of issues that he talks about. Another category of issues that he talks about is the idea that we haven't completely adapted to certain functions. That, in evolution, things keep getting redesigned as conditions change. Even though, for example, we have evolved certain structures of our skeletal system and our muscles and some other things that allow us to walk on 2 limbs rather than 4 limbs, like our ancestors did, evolutionarily speaking. Even though that has happened, that doesn't mean that it happened suddenly or that it happened in the most efficient way possible. If we were just starting from scratch and an engineer was designing things, it could be a lot more efficient and a lot less prone to some of the injuries and other dysfunctions that happen. So his point is that, yeah, we're adapted, but not necessarily adapted in the best way. And then he's got a third category of human errors, as we're calling it in the title, that are due to really just the limits of the evolutionary process. Usually evolution occurs in just very tiny steps, and it takes a very, very long time. Maybe in 1,000,000 years, certain of our structures and functions will be more efficient than they are now, but probably not. And that's because over time, there are just some things that we can't do because it's just these tiny changes that happen one on top of the other, happen on top of the other, and you can't necessarily just jump to the most efficient formation or the most efficient arrangement that there is. I'm not doing a very good job of explaining his story because it's not my story, it's his story. So I think the best way to learn about this, and I think it's something that, for me at least, it's really informing how I understand human structure and function. And it is certainly going to affect the way I tell my story, coming from the angle that I'm coming from, which is just learning the basic structure and function of the body, the story I'm telling to my students. So I suggest you listen to his story and see how that affects your story. And the only way to do that is to get the book. Just go to the ampprofessor.org/book club and you can get a copy for yourself. A searchable transcript and a captioned audiogram of this preview episode are funded by AAA, the American Association for Anatomy, at anatomy.org. This is Kevin Patton signing off for now and reminding you to keep your questions and comments coming. Why not call the podcast hotline right now at 1-833-LION-DEN. That's 1-833-546-6336. Or visit us at theapprofessor.org. Hey, and why not take just a moment, really, it only takes a moment, this week, and do it this week, to share the A&P Professor podcast with a colleague. As a matter of fact, now's a good time, right? Because it's the end. That's the end of this preview. So go right off now and call or email or tweet or whatever you do with your colleagues and tell them about this podcast. and I'll see you down the road.